Good morning, everyone. Today, in our lecture series, Analog and Digital Communication lecture series, we are going to see the pulse communication topic. Let's see the topic. So, already we discussed continuous wave modulation method in the previous lecture. That is amplitude modulation, angle modulation, that is frequency modulation and phase modulation. And this pulse modulation is one type of a modulation which comes under the modulation technique. So the pulse modulation having two types, that is analog modulation and another one is a digital modulation. Analog modulation, again we have three types, that is PAM, PWM and PPM. In digital modulation, we have two types, that is pulse code modulation, we usually call it as PCM, and another one is a delta modulation, that is DM. Now let's start with pulse modulation. What is actually pulse modulation? So pulse modulation here is nothing but of the modulation process is common for continuous wave and pulse, where the carrier signal will be used and the carrier will be modified according to the input signal. So here the input is pulse. So according to the pulse input signal, the carrier signal will be varied. So this is called a pulse modulation. Here, as I told already, there are several types of pulse modulation. So PAM, PWM, and PPM, like that I told. Here the case is here the varying the amplitude or polarity, presence or absence of duration or occurrence in time of pulses given rise to the four basic forms of pulse modulation. That is here. And the process of transmitting signals in the form of pulses, that is discontinuous signal, by using special techniques that I told you already, PAM, PWM, and PPM and PCM. So the corresponding waveforms are given in the slide. And why we require this kind of a pulse communication? That means we already we know very there is a very familiar concept, that is analog digital conversion, where the original analog, that is a time and amplitude continuous information signal S of t, is changed at the transmitter into series of regular occurring discrete pulses whose amplitude are of fixed and finite number of values. So for this concept, this kind of pulse modulation is uh, needed. And what is pulse amplitude modulation? That is PAM. So successive sample values of analog signal S of t are used to affect the amplitudes of corresponding sequence of pulses of constant duration occurring at the sampling range. So you just to see this diagram, circuit diagram, where you can easily understand the pulse amplitude modulation. So in a pulse amplitude modulation, we have two types. One is a natural sampling, another one is a flat tap sampling. In this natural sampling, the input signal, I told you, there is an analog waveform, and the carrier here used as a one sequence of pulses. So according to the input signal, analog input signal, the carrier wave will be varied. In terms of amplitude variation will take place. So finally, we are getting the output like this. This is called a natural sampling. And another type is flat top sampling. Here, the amplitude level of the waveform, that's pulses, will be flat. So that's why it is called as a flat top sampling, where in the previous, that is a natural sampling, here the shape, the amplitude level of carrier pulses will be uh, in align with the amplitude of the input signal. That is called a natural sampling, and this one is a flat top sampling. And next one, pulse with modulation. In the previous thing, PAM, pulse amplitude modulation, I told, with respect to the amplitude of the message input signal, the carrier pulse amplitude will get varied. Here, in this case, pulse with modulation, according to the amplitude of the information signal, that's analog signal, the pulse of the carrier waveform will be varied. If if the amplitude of analog voltage will be increased, the pulse of the carrier signal will be increased proportionally. So this is the concept where the amplitude will be remains constant in PWM case. So there is a difference between PWM and PAM. And this is the concern circuit diagram where we can get the PWM signal. And what is pulse position modulation? Where in the name itself you can understand the position of the pulse will be varied according to the analog voltage or the information signal or the input signal. This is called PPM, and the corresponding circuit is given here. And this is the comparison. So we have seen three techniques under the pulse communication, that is PAM, PWM, and PPM. So the corresponding comparison is given here. So already we have seen what is PAM, PWM, and PPM. In the case of some parameter wise, we have some comparison. In case of PAM, bandwidth of the transmission channel depends on the pulse width. In case of PWM, bandwidth of transmission channel depends on the rise time of pulses, and here bandwidth of transmission channel depends on the rising time of the pulses. Likewise, we have some comparison is there, and in the case of system wise, system is complex to implement. That is, a PAM is very complex thing to implement practically, and PWM system is simple to implement, and PPVM also simple to implement. So these are only some comparison between the various pulse modulations, and the corresponding waveforms also here compared. So first one, typical signal, that is an information signal. For the information signal, how the PAM signal will be coming as the output, that is given here in PAM, and below that PDM. This PDM is also called as PWM, pulse width modulation, and PPM. So thank you. The next class we will see the other types of pulse communication. Thank you.